Hello everyone and welcome back. Today we'll be solving another interesting question and the name of the question is Sum of No. Here is the question. Aaron wants to visit Central City. There are n bus stops in the Central City forming a binary tree and each node contains a number of passengers present in the bus stop at that stop. He decided to enter and leave the bus only at those stops that are present at the leave node of the binary tree. Suppose he is in the bus at A stop and left the bus at B stop. So he asks you to select those two bus stops A and B and find the sum of A and B such that the value of A and B is maximum. And how do you say that's maximum? Basically, the sum, that func of A and B, function of A and B, is sum of values in the path from root to A plus the sum of values from root to B minus sum of the values common for both this intersection of A and B. Okay, so your task is you don't have to pray, you don't have to take an input, just read the maximum that takes the root and the tree as parameter. Okay, so the question is pretty much straightforward. Let's head over to the whiteboard and I'll discuss it further. So let's assume that if you have a binary tree, here it has been told us that it's going to be a binary tree, okay? And I have here A, B, C, D. Let's assume it's a small binary tree and this actually alphabets are some numbers, okay? This is actually a numeric one, but I just replaced it with some variables. And what is this question is asking us right now is that you have to select two bus stops, which is going to be leaf nodes, okay? And you're going to call them A and B. For our convenience, I'm going to call them P and Q, okay? Or let me just erase this and write it here, different names. That makes pretty much sense. Here's C, D, E, F. Okay, we're going to have this A and B. Uh, and we have to select A and B in such a manner where from root to A plus root to B minus A to B. If there is any common path, you have to minus. That should be maximum. Okay. So in this case, you have four paths from root to the leaf because there are four leaf nodes. That is this node, this node, this node, this node. Now let's go ahead and put in some values instead of this x, y, z. I have 10. I have 20 here, 20 here. Okay, and then I have 4, 5, 8, and 10. So in this case, right now, if you try to pick 4, okay, so from root to 4, so I'm going to write all the 8, like root to 4, you're going to get 10 plus 20 plus 4, that is 34 here. Here you're going to get 10 plus 20, 30 plus 35. And here you're going to get 10 plus 20 plus 8, you're going to get 38. And here you're going to get 10 plus 20 plus 10, which is 40. So if you look at this nodes all together, it's actually the maximum that you're going to have is this and this. But out of this, you're going to remove this 10 and 20 to be honest. So what my answer is going to be like 40 plus 38 minus 10 and 20, that is 30. Okay, guys? So you're going to add from root to root minus this common thing. And I think that's what the sum is also talking about. Okay, and then pretty much the same. So what we can do is in this part of the code, all you can do is like first find out the maximum path, okay, and then you can put in those values and then subtract the path. So I will quickly give you guys a thinking pause so that you can come up with your algorithm, okay. But before that, let me just explain you with the sample example here. So he has given some tree and the representation of the tree here is something like this. So if you look at this tree, the maximum you're going to have the leaf nodes are this 11 and 12, correct? So he's considering 11 as one stop, 12 is one stop, and then he's constructing entire root to A, root to B, and then the intersection of that, subtracting, you get 41. It's similar to what we have done over here. Okay, so now go ahead, pause this video, try to solve it by yourself, and then I'll show how are we doing it. Okay, guys, so let's get back and try to solve this question. So in this question, honestly, I wouldn't be doing any fancy algorithm. All I'm gonna just do is do a DFS, do a recursive search from root to to the very bottom of it for every leaf node. Okay. And at every step, what I'm going to do is I'm going to just construct my maximum left side leaf node and right side leaf node, and I would be subtracting the common path and just continuing that step for each and everything. That's it. So pretty much the same at every step. A DFS, let me write a DFS algorithm. At every step, I'm going to construct my left max sum and right max sum, and in a global variable it called res is going to store this lms plus my the max of either this or right side, and then I am going to call my recursively go further and return back the maximum of this plus this by that. That's it, guys. That's what I'm going to do on the whole sum. But yes. So let's go. I feel this question is one of those questions where it's very heavy in implementation than actually coming up with an algorithm. Okay. Let's see how the implementation works. That's it, guys. So let me quickly check if I haven't introduced any syntactical mistakes. Absolutely. A minor mistake here. I was writing ref when it should be right. I think that's just right. So, as I suggested, I'm just, at every step, I'm trying to go deeper and deeper and find the left max and right max and from the root max, what is it that thing is. And eventually, I'm just being greedy at every step. A typical DFS search, guys. But recursively, I'm checking at each and every step, and eventually, I'm just returning that back. Whether left is max or right is max or the root is max. That's all, guys. That's about this question. Let's try submitting our code. So one more, a quick summary to the question. What we are doing is we are having this path sum, so which is going to include all the paths so far. So at every step, when you're going further and further, you pass this value to the path sum and you subtract that path sum once there is a intersection between both of the nodes. For example, if the root of left and the right they both belong. That basically means that they have a common path so far. So you remove that common path from here from the root fxy. Else you just continue and at every step you just add the root value to the guys. That's it. That's what you're doing at every step, and you pass that path value to the all the recursion calls, and it has been accepted. You can see here pretty much straightforward, typical DFS search, but searching at each point on your left max or right max or including the root. What is it? Okay, guys, so let's quickly run through our current algorithm with this input step by step. Okay, I just drew the diagram. Let me get the code right here for better understanding. And probably I can just cut short a part, some part of it. Yep, totally makes sense.
Okay, so here is the entire part of it, and initially, this is where our code begins. Okay, so let me just run through it one by one with the recursion tree. So initially we have this recursive function which is going to give us the eventually the answer, okay, and we are passing the root, the path sum, and the maximum leaf sum. So as you can see here, the current path sum is 0, okay, and the leaf sum is also 0, makes sense, and then we pass it out. And the moment, and this is what the breaking condition is for our recursion, that the moment you don't have any more root, you just return 0, and then you see the maximum max leaf sum at that point in time is 0, and which is absolutely correct. So because if you go to the left side of this, which is null, and you're going to get nothing but a 0. So that's what we have to find. So we start from here. We send out the very first time, the very first iteration. We start from the first node, that is the root node, which is 8. Okay. And initially the path is, let me just write out what is the path so far. So the path is initially the 0. And the moment we come here, so the very first statement here executes. I'll just write out the statement numbers. This entire thing is I'm going to call 2. Then I have 3, 4, and 5. So the moment the step number 1 executes, your path sum gets added with the root value, which is 8. Okay, so the current path is 8. So far, you have the path of 8. Then you check. If you don't have your root of left and right, that basically means that you have reached the leaf node, because that's what we call a leaf node, right? Where we don't have the root and leaves, sorry, left and right, right? So this will come back later. Post that, what I'm checking is I'm going to the left side. I'm trying to get the leftmost maximum sum, okay, or the maximum root node that I can have. So what I do is I make a call to the left side. This sir, I'm going and I'm passing the path sum with the max a leaf sum, which is 0 at the moment. I don't have any leaf sum. So going ahead, what do? I send it again, and this time I have, okay, let me just change the color for all the left side. So here I keep it 10. This is the second call. So let me also make a call stack just for a better understanding purposes. So initially I had 8, then I made a call to 2. So right now we are serving the second node, okay, sorry, 10. So this is the second iteration that I am here, okay. So once I come here at this particular node, what am I do is I check if it is root, if it's not a root. If it is a root, so it's not the end and you do have a value. So what you do, you execute the step number 1, and the current path that you get is 8 with a 0. Okay, so what do? I update my path. I do my path equals to 8. So I add 10 to it, which is the value. So look at here, we add the root dot value, correct? So I just add that up, you get 18, and that's a great thing. So you continue. This is not a leaf node, so this is just a leaf node or a not, which is not. I skip, I go, and I make go further left. So again I go further left, I can call it. So here in the stack you're calling the 11th node, okay guys, and then you again pass out the root dot left, which is 11th, and then path sum, which is so far is 18, comma again the leaf max sum, which is 0. So far we don't have anything, I'm just considering 0, guys. Okay, so you have 18. Again you come here, the I still exist the root, and the current root value is 11. So you just add this 18 plus 11 to it, and you get I think here it will be 9 and 2. So far the path sum, like from the root to the leaf, it is 29. And now at this moment in time, this condition gets true. The second statement gets true because you don't have your left and right. So that basically means that it's an end of that particular tree. So we consider this the max leaf sum equals to the path sum. So max leaf sum so far, which is nothing but this 0 that we are passing, the max left leaf node, is equals to path sum, which is of 29. So you written 29 here, okay, you written 29 here. So what are you going to written? not basically written, you're just, saving, updating that left max leave some value. That's all you're doing here. You're just updating your left max leave some value, which is 29. Okay. And then you further go back to the very person who called you. So that basically means that while going back, this is where you hop back, you say it's 29, and then you go back here, the very guy who called is 29. Okay. So before going that much further, so this is done. You stop here. Your value. Okay, let me just erase this part. Yeah, that makes sense. So you're done with your 11. That is out of the stack. Now you come to 10. So once you come to the 10, so this part is executed. Now you go to this part of the code from the 10th node. So what do? You again go to the right side of it, and then you try to get the max sum out of that. So far here we know that the path sum is 18. You just added it up here. Remember, it's 18. That's what we have passed. So you pass the same value, which is 18 and 0, because that is the right max leave sum. And to that 18, you add 18 plus 12, and you get, I think, 30. Okay, you get 30 out of it. So once you make a call out of here, so the right max leave sum here is going to be 30. Okay, so once you come here, you call again on top of 12. You come, you add the root value, that is the 30 it become. And then since you don't have a left and a right, you stop there, you return 0. Okay, you eventually return 0, but your max leave sum, which is nothing but the right max leave sum, the value which you have sent, which is 29, is coming from the left side, and you get 30 coming from the right side. So this is what you've written: 30, 29, and 30. So once this is done, so sorry, let me add 12 here, and then that is done. And then you come back to the 10th node. So right now at 10th node here at line 3, I think so. That's what I have. 5. At line 5, you have both the values. You have your left max leave sum, you have right max leave sum. So it is 29 and 30 at the moment. So out of this both the values, you are going to take the maximum out of it, which is 30. Okay, so you have 30 as your max. So we call this as your max out of this, both of these values. Okay, you call 30. You save that here in the max leave sum, and then you construct again. So what is your left value is here is 29. 29 plus 30 minus the common part. Okay, so the question was always talking about removing the common part. Remember, here also you have seen, I have told you and talked about this. So here the 11 and 12, it's that's where the values are different, but this 18 is similar. That's how you got 29 and 30. Remember, so this 8 and 10 you have to remove. That 18 needs to be removed, the common. So that's what we are doing. 29 plus 30 minus 18, just as we are told in the example. So we are removing 29 plus 30 minus 18. So if you can see, root of, if I have, then remove the path sum. So I do have, and I'm removing the path sum. So once I do this, what do I get? Can anyone guess it? It's 41, guys. So I get 41 out of that. And then what am I going to return? I'm going to return the max between the root left FYI, comma the max of this. So currently I have all my values in place, and then this recursion continues. Out of this, I think you're going to get, you're going to send back your left is 20 and your right is 30, and then you just return the values. Okay, and then you continue that. Again, the continuation of this leaf node will go on like once the 10 is done. Once the 10 is done, you again push 5 into the stack, and the recursion continues. From 5, you again push to the 2, and then you will get, I guess 2, I think you will get here 8. Then from 8 plus 5, you get 13 here. 13 plus 2, you return 15 as the left max value, and then from here you send 13 plus 4, which is I think 17, as the value. You again pick what of the values are the best. So this recursion continues. You go back to the file, you will have your max, and then just return the values. That's all the question is all about, guys. You will be returning the max values out of it. You will be greedy. Here it will be 41 and out of this, and then you get some lesser value from here, and then eventually your 8 is going to take max of this and this. So this is what the recursion stack looks like, guys. Here I just explained the approach, and here's the recursive approach.
Thank you so much, guys.